This is just a short overview of solutions. We've been talking about properties of liquids and solids and gases, and now let's talk about combining them all to produce solutions. The definition of a solution, it's a verb and a noun, but at any rate, it is a substance that has a gas, liquid, or solid dispersed homogeneously in a gas, liquid, or solid. Okay? Doesn't involve a chemical change, but the components are molecularly dispersed. They don't exist in clumps. They exist in single molecules or atoms. Okay, let's talk about the two different things we talk about when we're talking about a solution. We have the solvent. Generally, this is the liquid when we're talking about an aqueous or a liquid solution. But in general terms, it is the component that is present in the greatest amount. What we call the solute is the component of the solution that is present in the smallest amount. And in chemistry, that's often the solid. However, solutions can be between gases. The atmosphere we breathe is a solution of gases, where nitrogen would be considered the solvent, and all the other gases that are dissolved in that solution would be the solutes. In order for a solution to occur, three things have to happen. In the solute, you have to break solute-solute interactions, and these can be dipole-dipole interactions, hydrogen bonds, van der Waals or dispersion forces, and if it's an ionic compound, we have to break lattice forces, the ionic forces. Likewise, in the solvent, we have to break solvent-solvent interactions, which again could be dipole-dipole, hydrogen bonds, or dispersion forces, or in a very high temperature solutions, we would have to break the ionic forces holding those particles together. Then we would create new solute-solvent interactions. And once again, these can consist of dipole-dipole, hydrogen bonds, dispersion, or ionic forces. You may have heard this term, and if not, it's a useful thing for the rest of your life to know that like dissolves like. So polar solvents dissolve polar solids and liquids and ionic compounds. So water is a great solvent for many ionic compounds, as well as sugar and alcohols, because sugar and alcohols contain polar groups. Whereas if we want to dissolve something like oil, we need a non-polar solid or liquid. And in the case of oil, methylene chloride is a great solvent. Hexane is a great solvent. But if you should know what you're trying to dissolve and get rid of, and use the appropriate solvent. When we're talking about solutions, we often want to know the concentration of a solute in the solution. And in chemistry, the one we use most is molarity. The symbol for molarity is a capital M, and of course it means the moles of solute per liters of solution. Then we have another one that is often used when we're talking about colligative properties, which I'll introduce at the end of this video. The molality. And the molality has a symbol. It's not completely agreed upon, but generally it's an italic lowercase m, and it is the moles of the solute per kilogram of solution. So you may know that when water is concerned, 1 liter of water at 4 degrees C has a mass of 1 kilogram. However, volume, liters, is a temperature dependent variable. So as the temperature increases, the volume increases. And so molarity is a temperature-dependent concentration term, whereas molality is not dependent on temperature. Another one that we can use, it's not often used for liquid solutions, but for solutions of gases, it's quite often used, and that is the mole fraction. The mole fraction is given for each substance in the mixture, and it is equal to the number of moles of that substance divided by the total number of moles of all the components of the solution. And then we have mass percent. And mass percent is the mass of the solute that you're interested in divided by the total mass of solution, not the mass of the solvent. Remember, this is the mass of the solution. So if you have 40 grams of KCl and you're dissolving it in 60 grams of water, the mass percent would be 40 grams of KCl on the top here over 100 grams of water, or 100 grams of solution. You have to add those two together. Speaking of solubility, let's talk about the factors that affect solubility. Most solids have a solubility that increases as the temperature increases. Not all. You can see there's a couple here, sodium sulfate and cerium sulfate. Both have declining solubility with increasing temperature, but for the most part, most solids have a higher solubility at high temperatures than at lower temperatures. But gases are another story altogether. The solubility of gases decreases with increasing temperature. Okay, so as we said, gases are temperature, or the solubility of gases is temperature dependent, but it is also dependent on the pressure of the gas above the solution. So the solubility of the gas is proportional to the pressure of the gas, or the partial pressure of the gas, over the solution. This is called Henry's law, and it is stated very simply. The concentration, generally in moles per liter, is equal to this constant times the partial pressure. And this constant is good for whatever it's temperature dependent. The last thing I'm going to talk about in this video is I'm going to introduce the topic of colligative properties. Colligative properties are those properties that depend on the amount of the solute in the solvent, but not necessarily the type. Not usually the type. The type can have some effect, but it's for the most part, doesn't matter whether what you're dissolving is ionic or covalent, or it does have to dissolve, but it doesn't really matter what type it is after that point. The 4 colligative properties that we're going to be talking about in this class are freezing point depression and boiling point elevation. So when you dissolve something into a solvent, generally the solvent's freezing point will go lower. It will be at a lower temperature than normal, and its boiling point will be at a higher point than normal. Also, the vapor pressure of that solvent will be lower than it would be if it was a pure liquid or a pure solvent. And then we're going to talk about osmotic pressure. And osmotic pressure is related to concentration. So the higher the concentration, the higher the osmotic pressure, but it has to do with the with properties that go along with osmosis, and those will be dealt with in future videos. So we talked about what a solute and a solvent are in a solution. We also talked about some concentration parameters. We said like dissolves like, and we talked about temperature dependence of solubility as well as pressure dependence of solubility.